Alright, so this is partial fractions decomposition part 3. The last kind of technique and skill you need to know is how to handle a irreducible nonlinear factor of your denominator. So an example of that would be, like, say we wanted to decompose, and we're not going to worry about integration, but say we wanted to decompose 2x cubed minus 4x minus 8. And that was over x squared minus x and x squared plus 4. Okay, so first check, is the degree of our numerator less than that of our denominator? The degree of this is 3, the degree of this is x squared times x squared is 4, so we're good there. So let's try factor our denominator as much as we can. So our top's going to look like 2x cubed minus 4x minus 8. And, well, this is x times x minus 1. Now this is non-factorable. There's a lot of reasons why it's non-factorable in real algebra. So we have to leave it as x squared plus 4. Now, right now you're thinking maybe, how come we don't factor the numerator? Well, we don't really need to factor the numerator because we're not trying to make our numerator equal to 0 at any point, or any factor of it equal to 0. So all we're really going to be doing here is sticking in values for x when we get to the part where we want to solve for our coefficient numerators. So we can just leave this however we really find it. Whatever's most convenient. Usually you put it in order of descending powers of your variable, like it is here, but really it's whatever's convenient. But I digress. So here, the degree of this factor is 1, and the degree of this factor is 1, but the degree of this factor is 2. So when we make our stated relation of a over our first factor, which is x, plus b over our second factor, which is x minus 1, plus, okay, instead of it just being c over x squared plus 4, we have to put cx plus d over x squared plus 4. And this is kind of just a nuance you have to pick up, but basically the explanation is that the degree of your denominator will always be, when you do your partial fractions decomposition, will be 1 less than that of your numerator. So say we had a irreducible or non-factorable say cubic factor. So we had x squared plus x cubed plus 7 or something like that. Then our numerator for this term would be cx squared plus dx plus e. Right? So the degree of our numerator has to be always 1 less than that of our denominator. So since the degree of these are both 1, the degree of our numerator is 0, which means they're constants. But up here, because the degree of our denominator is 2, the degree of this has to be 1. So we're going to have some constant times x plus some constant, probably. Okay? It may work out that c equals 0, and then problem solved. It becomes pretty simple. But we'll hit that bridge when we get there. So this is the only real special part about this this part of decomposition, when you have your irreducible nonlinear factor. So otherwise all the steps are the same. So we want to give this denominator. So we'll have to multiply a over x times x plus 1 times x squared plus 4 times, x minus 1 times x squared plus 4. So then we'll have x times x minus 1 times x squared plus 4 plus b. Well, we have to multiply it by these two things here, x and x squared plus 4, so it'll look like b times x squared plus 4. And then the denominator of this will be x times x minus 1 times x squared plus 4 plus cx plus d Now we'll have to multiply this by x and then times x minus 1. So times x and then times x minus 1. And that'll give us our common denominator of x times x minus 1 times x squared plus 4. Alright, and this is all still equal to this, which is 2x cubed minus 4x minus 8 over x times x minus 1 times x squared plus 4. Alright, this, if we combine these, it'd have this plus that all over this single common denominator. So let's just kind of skip that step for convenience. We know what is happening if you've seen the other two videos, so we can just go ahead and set this numerator equal to the sum of all these numerators. So 2x cubed minus 4x minus 8 equals a times x minus 1 times x squared plus 4 plus b times x squared plus 4 plus c x plus d times x minus 1. Alright, so what are some, I think we're going to need a little more paper space over here. What are some convenient values? Well, a good obvious convenient value would be x equals 1, because then that would make this disappear, because x equals 1, that makes this 0, and it'll make our a term disappear, and it'll also make our c and d terms disappear, so we'll be able to solve for b. So let's try x equals 1. So we'll have 2 times negative 1, 1 cubed is just 1, minus 4 times 1, which is 4, minus 8 equals a. If x equals 1, then x minus 1 equals 0. So all of this times 0, that's going to be 0, plus b times 1, so that's still just b, times 1 squared, which is 1 plus 4, so this will be 5, so b times 5, plus, well, x minus 1. If x equals 1, then again, this will be 0, so this whole thing will be 0. So we'll have 2 minus 4 minus 8. So 2 minus 4 is negative 2 minus 8, so we have negative 10 equals 5b. So negative 2 equals b. Alright, we're off to a good start. What's another good convenient for value for x? So here we have b times x and our CD term times x. So let's try that. So what would make these disappear? X equals 0, right? Because anything times 0 would make this equal 0. So let's go with x equals 0. So if x equals 0, that's 2 times 0 cubed, well that'll be 0, minus 4 times 0, which is 0, minus 8, equals a times 0 minus 1 is negative 1, and 0 squared plus 4, that's 0 plus 4, that's 4, plus b times x is 0, so this whole thing's going to be 0, and this whole thing times x, and x is 0, so this whole thing will be 0. So plus 0 plus 0. So here we're left with negative 8. Here we're left with negative 8 equals negative 4a. Right? So then, now, we know that our divide both sides by negative 4, that 2 equals a.